Hello, everyone. Thank you for being here. My name is Spencer Deame. I'm the marketing manager at NextEra Video. We're technology providers for 2110 cores, IPMX, and NMOS. Today, I'll be talking about the evolution of NMOS for 2110 and IPMX. So a little overview. I'll talk about what is IPMX, or what is NMOS. I'll give an overview of some of the NMOS specifications. I'll talk about some of these NMOS use cases for broadcast, and finally move into what is the evolution like? How are we using NMOS for Pro AV and IPMX? I'll talk a bit on security and how we can test NMOS, and finally how you can try it on your own. So what is NMOS? You may have heard a little bit from Steve's presentation previously, but NMOS stands for the Networked Media Open Specification. It was developed by AMWA, the Advanced Media Workflow Association, and this is delivered in the form of an open spec on the AMWA website. Essentially, the goal of NMOS is to allow 2110 and IPMX devices to be completely interoperable, and this gives us the plug-and-play and push-button simplicity for AV over IP. So there's actually a lot of work being done in AMWA right now to sort of organize all of these specifications in a more logical way. You may have seen some of these IS specifications, and it can be a little bit of alphabet soup. So the work that's being done now, brand new work, is sort of organizing these in a logical manner. AMWA is calling these two logical groups NMOS Connect and NMOS Control. NMOS Connect is related to the resource and connection management, whereas Control is extended for device control and monitoring and configuration. So within NMOS, I'll be talking mostly about NMOS Connect in this presentation, and then there will be future presentations on NMOS Control. Within NMOS Connect, we have things like ISO 4, which Steve talked about in the previous presentation. And there's these other specifications that build on ISO 4, things like annotation, grouping, asset info, system resources. ISO 5 is the connection management, which I'll be talking about shortly. And there's also other things we can do with the connection, such as audio channel mapping, tally, all sorts of other things. And then finally, receiver capabilities. There's a lot of work being done to support all sorts of different codecs, things like JPEG XS, H.264, 265, NDI, you name it. So, NMOS Connect. I'll talk a little bit about some of the broadcast applications. But first, why should we care? I mean, you guys are all here. You're here because you care. You know, in the early days of IP, there was a lot of manual configuration of all these IP addresses, and someone has to sit behind their computer and type in all these IP addresses. It's really costly. It's expensive. It's time consuming, and people can make errors. So NMOS was developed to make it all plug and play. Plug and play is fun. That's good. In addition, pretty much all the new facilities are specifying that you need to have NMOS in your facility, and most of the control system providers have fully embraced NMOS. In addition, the EBU released this paper a couple years ago, this Tech 3371, and this is the minimum user requirements for an IP facility. And in this document, what they say is your media facility shall use ISO 4, it shall use ISO 5, ISO 7. So EBU cares so much about this NMOS specification that they've mandated it in this document. And in addition, they've developed this testing program. This is called the JTNM Tested Program, where NMOS vendors go to this interop event and are able to test to make sure that their devices conform with the specifications. So, how does NMOS work in a nutshell? You may have seen in the previous presentation these NMOS devices. So you have NMOS devices that are connected to the registry, the RDS, and the control panel will query that registry. And it'll say, okay, what are all the devices on the network? I've got 2 cameras and a monitor. the registry can actually populate that control panel and show you all of the different devices on the network. When the control panel is activated, someone presses a button, that's your source destination take, and that commands the monitor to switch streams. It says, okay, unsubscribe me from camera 1 and subscribe me to camera 2. So how is NMOS accessed? Say you want to look at this. Well, it's actually really easy. You can look at it on your own web browser, Google Chrome, Safari, whatever you want. It's just a HTTP link. So it's an API. You can go onto Chrome and say, okay, https:// IP address /x-nmos, and then your API name. So you're able to view all these on a simple browser. So I talked a little bit about ISO 4 in the previous diagram. So exactly how does ISO 4 work? You know, how does my controller know which devices are out there? Well, simply the controller, in this case, it's a Matrox Conduct IP, that NMOS controller advertises itself and says, hey guys, I'm out here, you know, here I am, I'm an NMOS controller. And it's sort of like a NMOS mating call there. And then the devices hear that and they're like, oh, cool, I like you, you're an NMOS controller, let me register. So how do we build on that? We have these devices that are registering to the NMOS controller, the network. Well, we can build on it in a lot of ways. We want to automate as much as we can, and we use ISO 9. So ISO 9 system resource is a way that the devices can see all of the global configuration parameters for a specific network. Things like heartbeat interval, timestamps, what the protocol is. So that's what we use ISO 9 for. So since we have so many devices from all different manufacturers adding themselves to this network, what would be a good way for us to organize these? We have so many devices. NMOS has developed this grouping. So we use grouping. We call it natural grouping. It's a way for all of our NMOS devices to have tags, and you know, it's kind of like a hashtag basically, but we call it group hint, tag, and roles. It's a good way for us to organize all of these devices on the network and say, what sort of device am I? So an example of this would be, all right, we have a playout server that's got one video flow and two audio flows. So an example of the group would be, okay, it's all playout master, but we have that one video role, or we have that one video flow and two audio flows. So the video flow, we could just say, we'll call it primary, but we have two audio flows that we want to distinguish from one another. So we can actually tag those and just say, okay, audio 1 is 2-channel audio, audio 2 is 5.1. So how do we build on this? Because say you have a lot of racks in your facility and you've got, you know, 50 SNPs. How do we know exactly what all these are doing and where they're located? Well, NMOS is built on that, and we have this asset distinguishing information. Basically, this is a standardized way to just say, okay, how are you going to say what type of device you are? In this example, you could say, well, you know, say I'm a SNP or something. So manufacturer is Imagine, product name is SNP. Then we have this instance identifier, which it allows us to say exactly where that device is in your facility. So say you have a problem with it, you know, you can look at this, say, okay, well, we named it, we described exactly where it is. This is floor 2, rack 1, position 5. That's our device. Okay, and in this example, you know, it's a SNP, that could be a multi-function box. It could do a bunch of different things. So how do we know what that box is actually doing? Well, that's this thing on the bottom here. We call it the function. So if that's been configured as a format converter, there we go. We say it's a format converter. You know it's programmed as that. So ISO 5 was also in one of my previous diagrams. And this is exactly how we do the switching. So you've had your devices that registered to the network, and then how do we do that push button switching? One of the best parts of NMOS, you're on your control panel, clicking a button, switching. This is done through ISO 5, and the way that we call it is it's activations, and these switching activations can be immediate, they could be relative, or they can be absolute. So for example, you could program it to say, I want to switch right now, or I want to switch in 5 seconds, or I want to switch at 12 p.m. We can support anything. So NMOS supports video, audio, metadata. And, think about the old days before IP where we had SDI and you had all these different audio flows, coming in. A good thing about IP networks is all the audio flow or all the flows are sent separately. So the video, audio, and metadata is all sent separately. It's all packetized. So NMOS can actually use that to our advantage. And if we want to route different audio channels, we can. This is done through what we call ISO 8. It's audio channel mapping. And this gives us the capabilities like we had in SDI where you can move around your audio flows essentially. So here's an example of what that might look like. In this example, it's a little hard to see, but we have 2 audio devices with 8 channels each, and we can have this nice little cross-point matrix to be able to just select where all of those individual audio channels are being routed to. You can even re-embed that back into an SDI stream and push it out. So what else can we do with NMOS? Well, what if we have a production switcher like this and, we want to light up a tally lamp or something like that? Well, we can actually use NMOS. We call it ISO 7 for event and tally. This is essentially GPIO over IP, gives us tally functionality. And what this does is it actually leverages ISO 5, and it says, okay, the production switcher wants to light up the tally lamp. There's a couple ways to do it. You can send a MQTT command, or you could send a WebSocket command. Depending on the size of your facility, there's pros and cons to each. So depending on, which command you send, we leverage ISO 5. The receiver sees that and then lights up the tally lamp. Okay, so those were some of the common use cases for what NMOS is used for in, traditional legacy broadcast applications. But nowadays, you may have heard of IPMX, and there's a lot of new developments. So how has NMOS evolved for Pro AV? So, in broadcast, we like uncompressed, but in Pro AV, they like compressed. So there's actually a way that we can use NMOS for JPEG XS. And this references the VSF TR10-8, which is NMOS for IPMX. And NMOS is actually required for IPMX devices. So this leverages ISO 4 and 5 that we already talked about, uses the grouping. And essentially the way that it works in JPEG XS is it adds a new media type called this video/JXSV. It says, I'm JPEG XS. So one of the biggest new developments for Pro AV and IPMX is this stream compatibility management. It's a mouthful. Essentially what this is it's just EDID. So in a Pro AV world, you have HDMI connections and, so you have your laptop and you're connecting to a TV like that. The TV knows exactly what resolutions it can support. It tells your laptop, okay, send me that resolution. That's what EDID does. So IS11 leverages this EDID, and it's a way for us to, within an IP or IPMX facility, say, okay, what are our senders and receivers capable of? So an example of this is, well, we have right now it's just kind of a traditional broadcast application. It flows one way. You got your PC going to a gateway into the network, to another gateway, and out to the monitor. But for Pro AV, we need to know what the capabilities are. So the way that works is the monitor sends an EDID to the gateway and says, okay, I can only support certain resolutions. The gateway also says they can only support certain resolutions. So these are the constraints, the capabilities rather. So say one gateway can only support 2160p or JPEG XS, HDCP. The monitor, say, can only support 4K. So what happens is the monitor tells the NMOS controller, the NMOS device will tell the controller, hey, there's some constraints in the system here. You need to make sure that we send the right resolution. So it'll tell the transmitting device, you can only send 4K because that's what the monitor is going to take. So what happens is that transmitter will send a new EDID to the PC here, and then the PC will send the correct resolution there. So all of this NMOS stuff sounds great, right? We're working with IP facilities. Well, what about security? We want to make sure that people are authorized for the system. So there's a lot of things to address this, a lot of work being done with an AMWA for security specifically. A couple of quick examples here are, we're using TLS and HTTPS. You may know, like if you're going on your web browser, some websites are HTTP, some are HTTPS. So we're leveraging that HTTPS to be more secure. There's also a lot of work being done for authorization of users to make sure that you have to be authorized to actually log into this IP network and do your switching through NMOS. And then there's also certificates that we're using. In addition, there's also authorization, which is IS-10. So this is essentially specifying how are we going to authorize the users? What's the method of authorizing users within this IP network? An example of this is, well, we have our broadcast controller and we have some IP sources and destinations. Well, we use an authorization server, and the controller will send an authorization request to the server. It's a OAuth request, and it receives this JSON web token. Then the broadcast controller wants to send an activation to its IP source. So in addition to the activation, it also sends that JSON web token to the source. And at the same time, the source is getting its public key from the authorization server and making sure that the key matches the web token. So once that is authorized, then the source starts transmitting. Meanwhile, the broadcast controller sends its activation to the destination to actually do the switching. And at the same time, that destination is getting its public key, making sure that these match. And once everything's verified on both ends, this is when we can do our source destination take. IP destination subscribes to the source, and we've done our switch secure. So say you want to test your NMOS devices. Have you, say you've added NMOS to your devices and you want to test and make sure that everything works all right. Well, you can go to this GitHub link. AMWA has these automated NMOS tests that they've developed. And you can actually go through and test all of your IS specifications and ensure that they meet the requirements. So how can you try NMOS on your own? Well, Riedel actually has this Riedel NMOS Explorer. You can go to their website. I think Steve showed this in his last presentation, but it shows all the nodes, devices, senders, receivers, and you can drag one on the top of the other and do your switching there. Another good way to play with NMOS is this Matrox Conduct IP. And this is a good kind of cross-point matrix switch. You can see your senders and receivers, and you can do your routing here. You can also route your audio flows using that ISO8 audio channel mapping that I mentioned earlier. Lots of things you could do with this Conduct IP. So, in conclusion, ISO4 are stable, mature, offered in pretty much all the new 2110 products. They're required for IPMX products, so we'll continue to see these. In addition, the control systems are greatly improved thanks to spec clarifications and all of the interop testing that's being done. And there's a lot that we're currently building on NMOS that I just showed, things like ISO 809 for discovery, all the grouping that makes things really easy for system integrators and everyone in the facility. And of course, we've added all the security that's been sorely needed for a long time. So NMOS is currently being worked on. There's a lot of great work being done AMWA, and ultimately someday hopefully we'll see device control and NMOS can be used to do all sorts of really cool things in the future. With that, I think I'm right on time. Any questions? Thank you.